Okay, so this is a 7.5 in trig, and what we're going to do is we're going to introduce the rest of the trig terms, stuff that you may be familiar with. Quickly to review, we talk about sine and cosine a lot so far. We have to remember that sine of theta is equal to our y over r. Okay, now we did end up saying that just ends up being the y value typically when we're dealing with a unit circle. But I mean, still, it's pretty much the same idea. So cosine of theta is x over r, which is basically equal to x when we're dealing with the unit circle. And now let's talk about the new one. So tangent is going to be y over x. And in this case, x cannot equal 0 because anything on the bottom of a fraction is undefined. We have cotangent of x is going to be the reverse of that. It's going to be x over y. And again, that would mean that y cannot equal 0. Our secant of theta, okay, so secant is going to be like the reciprocal of cosine, okay? So that's going to be r over x. And again, x cannot equal 0. And the last one, cosecant, is going to be r over y. And that's where y cannot equal 0. So again, all we're doing here is cotangent is going to be the reciprocal of tangent, secant is going to be the reciprocal of cosine, and cosecant is going to be the reciprocal of sine. So what does that mean in terms of sine and cosine? That's what we're going to write here. And this is where it's going to become important that we understand this. So tangent of theta is equal to the sine of theta divided by the cosine of theta. Cotangent will be completely the opposite, cosine of theta divided by the sine of theta. Secant is going to be 1 over the cosine of theta, and cosecant is 1 over the sine of theta. So that's what I mean by reciprocal. Okay, so we're just taking 1 and putting it over it. So secant is the same thing as 1 divided by the cosine of theta. Cosecant is the same as 1 divided by the sine of theta. Okay, so let's flip the paper over. Let's go to the back portion. Let's just start filling in these a little bit so that, again, we know what sine of theta and cosine of theta are. We've gone through this. So what we're going to do is just fill in this table. So we know sine of 0 is 0. Sine of pi sixth, which is 30 degrees, is equal to 1/2. And then we have square root of 2 over 2, square root of 3 over 2, and then 1. And then our cosine is completely the opposite, 1, square root of 3 over 2, square root of 2 over 2, 1 over 2, and then 0. So now tangent of theta, we can do a couple of different ways. We can either figure out what the sine of theta divided by the cosine of theta is going to be, because that's what tangent is, or we can still use our special right triangles. So 30, 60, 90, that would be 1, this is square root of 3, and this is 2, and then we have our 45, 45, 90. So that's 45. These are 2 square root of 2's, and then 2. So now, again, tangent in SOHCAHTOA is opposite over adjacent. So tangent of, first of all, sine over cosine. We have to do sine over cosine for this one. So 0 divided by 1 will be equal to 0. This one, again, we can divide if we want to, but we don't have to, okay? But we could, if we divide, it would be 1/2 over square root of 3 over 2. The 2's will actually cancel out, and we'll get 1 over the square root of 3. The bottoms would always cancel out on sets of fractions like that. Now again, if you look at the special right triangle, it works out that way. Opposite is 1, adjacent is square root of 3, 1 over square root of 3. Okay, 45, 45, 90. Again, if we're dividing these out, we would end up with square root of 2 over itself. That's just going to equal 1. If we go to the next one, that's going to be 60 degrees, pi thirds. Again, opposite over adjacent would give us the square root of 3. And then the last one, we would end up with sine over cosine would be 1 over 0. Well, that 0 on the bottom screws things up. We cannot have the 0 on the bottom of a fraction, so this is actually undefined. And that's important to know. So what you probably want to do is, using this table, if you're looking at this right here, this table, or our unit circle that we filled out on yesterday or Friday, what's going to happen here is you need to now understand when things are going to be positive and negative. So based on what we have done, we can now fill this in to actually figure out what is going to be positive, what is going to be negative in each of these quadrants. Okay, so we will work a little bit more with this when you guys come to class. We're not going to fill it in now, so we will fill that in when we work on this in class. So, but that's the idea. That's the reason why this slide is here. So the last thing we want to talk about is where are things undefined. Remember, things are undefined when the bottom of a fraction is equal to 0. So if you look at cotangent, cotangent is equal to 1 over the tangent, or cosine of theta over sine of theta. So you're really looking for when is sine of theta equal to 0. Well, sine of theta is equal to 0 at 0. So that means cotangent will be undefined when theta equals 0. That's the part, because that's when sine of theta is equal to 0. So it says when is cosecant undefined? Well, that's 1 over sine of theta again, and we've just determined that sine of theta is equal to 0 when theta is equal to 0. Now, one thing that we need to be aware of here, okay, this is very, very, very important, we haven't talked much about it, is theta is equal to 0, that works, but I hope you also realize that it could be when theta is 2 pi. Every 2 pi after that, it will work. Now, don't forget, it also will work at pi. So there's multiple areas where this works. There's multiple numbers or multiple thetas where it's going to be undefined, because sine of theta is going to be 0 at several different places. So we don't want to just define one thing. So here we have to make sure we say 0 in pi, definitely sine is 0 at 2 pi. So it's basically every pi after that, it's going to basically get back to where it's 0. And this is very important when you look at a sine graph, and this is part of what we did the other day. A sine graph looks like this, and it goes in both directions. And if you notice, it's 0 here, it's 0 here, it's 0 here, it's 0 here, it's 0, and it just keeps going on forever. And we need to understand that this is 0, this is pi, this is 2 pi, this is negative pi, this is negative. So there's a lot of answers that we have there, but you just need to know where they're at. Okay? So the last slide talks about when is tangent undefined. So tangent is undefined. So tangent is defined as sine of theta over cosine of theta. So when is cosine of theta equal to 0? Well, cosine of theta is equal to 0 at pi over 2. So we're going to say when theta is equal to pi over 2. But again, it's every pi after that and every pi before that. So it's going to be negative pi over 2. It's also going to be 3 pi over 2. 5 pi over 2. I mean, it just keeps going. It's cyclical. And then the last one, secant, is again 1 over cosine of theta. Again, we're looking for where cosine of theta is equal to 0. And that is, again, theta is the exact same thing. And we need to start getting comfortable with this. We need to know when our trig functions are equal to 0. That's super important. And remember, our trig functions are 0 when theta equals something specific. So it's like, what does theta have to equal to make our trig function equal to 0? And that's what kind of the point of this is. Okay, so that's all we have. Obviously, we will work more on this in class as we need to. I do understand that there's some new terms, so we will work at this. I will see you then. Don't forget to take your quiz if that has been assigned.